Let's study 9th standard ICSE Physics, Chapter 3D, Newton's Laws of Motion, Law number 3, Action and Reaction.
The first law told us force is required for motion. The second law gave us a quantitative description of this force. We have equations and mathematical models to calculate. But to understand motion further, we need a third law, which says for every action, there is an equal and opposite reaction. This spring balance is hooked to the wall. It is connected with another spring balance. If you pull this one, whatever force you observe in its measurements here will be equal to the force being exerted on this. Spring balance can be used not only to measure the weight, but any force, because after all, weight is also just gravitational force. If you exert more force here, perhaps this will go on to 6 kgf. Here also, you will see that the force exerted on this is 6 kgf, because this is applying a force on this, and this spring balance is applying a force on this, and both the forces are equal and opposite to each other. If the forces are equal and opposite, why don't they cancel each other? For example, if I shoot with a gun, the gun applies a force on the bullet, due to which the bullet moves forward. Simultaneously, the bullet will apply a force on the gun, due to which the gun will recoil backwards. That is why we feel a recoil backwards, because the gun is being pushed back by the bullet. So question 1 is that if the forces were equal and opposite, why didn't they cancel each other? Well, that's because both the forces did not act on the same object. They acted on two different objects. The gun applied a force on the bullet and the bullet applied a force on the gun. So they can't cancel each other. If two forces are on the same object in opposite directions and equal in magnitude, then they can cancel each other, resulting in zero force and zero motion. But action and reaction forces never cancel each other. Second question is that if the forces were equal, the bullet was shot with a great velocity. It moved ahead. But when an equal force was exerted on the gun, it moved only slightly. Why was there a difference? Well, that's because of the inertia of rest that they had. The bullet is very light, so a force of 500 Newton might be enough for it to be shot at great velocity, but that same 500 Newton is not enough to push the gun back much. Similarly, when you are rowing a boat with an oar, with the oar, you are pushing the water back, and you, along with the boat, is moving forward. So again, there is an action and reaction force here. The action is you pushing the water backwards, and the reaction is the water exerting a reaction force on your oar, and since you're in contact with the oar, on you, and since you're in contact with the boat, even on the boat. So the entire boat, you and the oar, move ahead because of the reaction force of the water. Another example is when a book is kept on a table. The book exerts a force, gravitational force, its weight downwards, and the table applies a normal reaction force upwards, equal and opposite, action and reaction. Pushing a wall. When I push a wall, the wall pushes me back with an equal and opposite force. Next, motion of a boat moving away from the shore. So when the boat is just at the shore, the first thing we do is with the oar, we push the land. And that's when the boat is pushed into deeper waters. Why do we push the land to start our journey on boat? Because when we apply an action force on the land exerts a reaction force on the oar, us, and the boat. Next, rocket motion. When a rocket burns fuel, the gases are pushed down with great velocity. A lot of force is exerted on the gases downwards, and the gases exert a reaction force on the rocket upwards, and that is why the rocket moves up. Such a heavy rocket can escape Earth's gravitational force. Motion of a man on the ground. When we are moving, actually our feet are pushing against the ground downwards and backwards, and the ground is providing a reaction force forwards. That is why we are able to move forwards. Actually, the reaction force is inclined, but we can split it into two directions. One is the horizontal component and the vertical component, split into two parts. The vertical component is of no use because we can't fly, but the horizontal component of this reaction force provided by the ground pushes us forward and helps us to walk. If there was no friction on the ground, if there was no such reaction force, we would never be able to walk. So next time you walk, just think about this. You are actually pushing the ground backwards. Of course, the ground won't move backwards if it's rigid. Rather, the ground will push you forwards. That's a reaction force. When you get off a boat onto the shore, the moment you get onto the shore, your boat is actually pushed back a little bit. The moment you moved onto the land here, you had to actually push the boat backwards. You had to push the boat backwards with your feet so that the boat could provide a reaction force to you forwards, and that is why you were able to go onto the land. So if the boat is not tied up to this shore, and if it is light enough, there is nobody else sitting here, the boat will move back. When you catch a ball, the ball exerts a force of action on your hands, and your hands exert a force of reaction on the ball.
Newton's third law of motion talks about action and reaction. And the statement is, to every action there is always an equal and opposite reaction. For example, if a book is lying on a table, the weight acts downwards, but we have an equal and opposite normal reaction force. And that's why the book is stationary. So this third law of motion is useful because it explains to us how force acts on an object. See, the first law gave us a qualitative description of force, and the second law gave us the quantitative definition and formula of force. But the third law explains how motion happens because of the force. Mark this note as a GR. Even here, GR. When you're pushing a wall, why do you experience a force in the opposite direction? Well, that's a force of reaction. That's a good reason. Motion of a boat moving away from the shore. When a boatman wants to move the boat away, he pushes the shore by a bamboo or his oar. That is the action. And the reaction is that the boat is pushed away from the shore. So this is a give reason. Similarly, another give reason is motion of a boat in water. When you row your boat with the help of an oar, you are pushing the water backwards. That is the action. So the water exerts an equal and opposite force of reaction in the forward direction. That is why a boat is moving ahead, thanks to the reaction force from water. Another give reason, when you fire a bullet from a gun, why does the gun recoil? Well, an action force is exerted by the gun on the bullet in the forward direction. Similarly, a reaction force is exerted by the bullet on the gun in the backward direction. That's why it recoils, although recoils quite less because the mass of the gun is much heavier than that of a bullet. Next give reason is about the rocket, which I've already explained. Next, motion of man on ground. And even the motion of women can be explained with a similar phenomenon. Now here, you are actually pushing the ground in the backward direction, and the ground is pushing you back in the forward direction, which is the reaction force. Imagine if there was no friction, we would not have been able to get that reaction force, and walking would have become impossible. That's why you can't walk easily on an ice sheet. Next good reason, motion of boat away from the shore while stepping down from it.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.